Hello, this is Geometry, topic 9-4 over dilations. So we're going to be talking about dilations, which is a process that produces a figure that is similar to the original figure. The scale factor tells us how much larger or smaller the dilated figure is. So let's go ahead and look at example number 1. We'll dilate ABC using a scale factor of 3, and T is the point of dilation. That means that we're going to do everything from T. So if I take my ruler and I measure the distance from A to T, it looks like it's 2.2 centimeters. So I'm going to go that times 3. So 2.2 times 3 is 6.6. So I'm going to come with my ruler and from center point to center point, I'm going to move 6.6. And this is my A. And I'm just going to do a little bitty dashed line here so that we can see some things. Okay. Now from A to B, I measure it from center to center at 4.9. So if I do that times 3, I get 14.7. So I'm going to go to 14.7. I'm going to put B, and I'm just going to draw a dashed line . And now we take a look at C. From center to center, looks like 3.5 times 3 is 12.5, so we go to 12.5. We put our C, just draw a dashed line. And so I've got my new A, my new B, and my new C. And notice that everything comes out in a straight line from T, because that's my center of dilation. To redraw my triangle, I connect A, B, and C. And I've got my new triangle. It is the same shape, but a different size, and it's been tilted just a little bit. So that's a dilation. This is called, we'll look further down the page, an enlargement. So reduction is produced by a scale factor less than 1. So if we take a look at our second page, now we're going to dilate by a scale factor of 4. So this is still an enlargement. So I measure from T to all of my outside shapes on the outside points. So this is 1.6 times 4. which will give us 6.4. So I come over here, and from center, make sure I'm going through 0. Through O, 6.4. That's my point O. For M, we go from T to M. That looks like also 1.6, so we need to go 6.4. From N to T, looks like that's right at 2. And 2 times 4 we know is 8. So I extend this out to be at 8. This is my new N. And then from L to T, looks like 1.9 times 4 is 7.6. So we extend this out. 7.6. That's my new L. Move my L down just a little bit. So I've got my 4 points. I now connect them. And we should get same size, and we didn't quite get that. Same shape, I mean. So I need to double check my measurements. Oh, this is at 1.9. Which should be 7.6. NT. INT is at 2.1, which is 8.4. So I need to go ahead and move this to 8.4. This is 1.2. So 1.6. That should be 6.4. 1.6, so we're looking for 6.4. So I need to come back through here and Adjust my picture just a little bit. Okay. And if your dilations aren't perfect, like this one's not perfect, as long as they're close, I'll go ahead and give it to you. I will double check your sizes, make sure that they are accurate. But other than just creating dilations, I want to make sure that you also understand how to tell if something is dilation. So we want to determine if these triangles are similar, and if so, determine how, and a statement of similarity. Well, this is actually a review. This is side angle, side, similarity, so that's yes. We give these triangles a name, JKL, would be MNP. So this was just a review from last lesson. Let's go ahead and take a look. Well, that's the last page for this. So, good luck on your assignment. Make sure that you take your time. Just double check your measurements to make sure that you get your measurements right. Your shape should be similar, at least close enough. I know that you might not get exactly the same. You can use either inches or centimeters, whichever is easier for you. Have a good afternoon. Good luck on your assignment.